Welcome to EDU World Space.
Okay, so we have two concentric spherical shells in a radius A, outer radius B of our inner shell, and a radius C, outer radius D of their outer shell. The inner shell has a total charge of plus 2q. The outer shell has a total charge of minus 2q, and we're going to find the electric field everywhere and where the charges are located. So let's get started. So remember that when you have a point charge, that the electric field is given by this. Remember what K is? K equals 9 times 10 to the 9. It's also equal to 1 over 4 pi epsilon. Epsilon is just a constant. Also remember Gauss' law. Here it is. Gauss says that the closed loop integral of E dot dA equals Q, the total charge enclosed, divided by epsilon. All right, so first region, radius less than A. Okay, we are right here in this little green dot. We have no charge there. With no charge, Q is 0, so E must be 0. Okay, A less than R less than B. We're in this inner shell, or first, our smaller shell. This is a conductor. One of the properties is that E equals 0 inside of a conductor, so must equal 0. B less than R less than C, so now we're in this first voided region. Well, what is the total charge in that region? Q enclosed? Well, it's just the charge of that inner shell plus 2Q. So now we can just imagine that it was a point charge and say that the electric field E equals 1 divided by 4 pi epsilon times Q, total charge inside, 2Q over R squared. There it is. All right, now we're in our outer shell, C less than R less than D, C less than R less than D. Well, do our Gaussian surface, we're somewhere in here. What is the total charge in here? Well, it must be 0. Why is that? We're inside of a conductor. So E equals 0. There it is. That was not too bad. Now what happens if we are outside of everything? So now what happens if we are doing a Gaussian surface outside of this system? Well, what is the total charge enclosed? Plus 2Q minus 2Q, that equals 0. E must equal 0 here as well. We can go ahead and graph this. 0, 0, so we have these regions of 0. B to C, right here, goes something like this. That's 1 over R squared. And then it goes straight back to 0. All right, now let's look at where these charges might be located. So what is the charge on the inner surface of our smaller sphere, of our smaller shell? So if we are looking at this region right here, well, I know that the electric field must equal 0 here. There's no charge on the inside. There's nothing induced. It must equal 0. 0. What about the outer? Go right here. Well, what is our charge enclosed here? Plus 2Q. It's everything. Everything is in there. We have an electric field due to a plus 2Q charge. There it is. Plus 2Q. What about our large shell? We go right on this inner diameter right here. Okay, we know that the electric field must equal 0 here. That means it needs to cancel with this plus 2Q that's happening right here. That means all of the minus 2Q is going to land at this surface. That's minus 2Q. Then what about this outer surface? It's got to be 0. We have a net charge of 0 here. So the outer must equal 0.